Hi there, I'm going to take some time today to walk you through horizontal translations with trig graphs. I'm only going to focus on sine and cosine graphs, or sine and cos graphs, and translating them left and right, and then the last example will have a vertical translation as well. I'm not really focusing on tan graphs today, so we're just going to work through the basics here with sine and cos graphs. Okay, so the first example that I've got here is a graph. It's just a basic sine graph which has been translated pi on 4 units to the right. So when you're faced with a horizontal translation, your aim should be to try and eliminate or exclude that translation and really just focus on the core elements of your sine graph, so looking at the period and the amplitude. So if I cover up that pi on 4 there, you can see our basic graph here is really just a sine graph. It's got a normal period of 2 pi. What we're going to do with that period is divide it into quarters, and then from those 4 quarters we're going to allocate 5 dot points, and it will be these 5 dot points that will form the basis of your translation. It's really difficult to do a translation without these 5 dot points and to do it accurately. It's also these 5 dot points that examiners will be looking for to decide whether you have performed the translation correctly. So as I said, I've got a basic sine graph. We've got one period within 2 pi, and you'll notice that I've actually just deleted here, through the power of my own personal eraser, I've deleted here the rest of that sine graph. I'm trying to show you what we as maths teachers see when we're looking at a sine graph. We actually visually get rid of that extra part of the sine graph, and that's what you want to try and aim to do as well, is block out the stuff that's not relevant. So anyway, back to these 5 dot points. The first 2 dot points are the start of the period and the end of the period. The third dot point is halfway in between, and the other 2 dot points make up the minimum and the maximum, which are really the quarter way points. So you've really got start, quarter 1, quarter 2, quarter 3, and the end. There we are, broken up into your 4 quarters, but creating 5 dot points. So we're going to focus on the x values because we're doing a horizontal translation. We're focusing on the x values moving left and right along our graph. So whatever your period is, you would halve it to get the middle point, and then you're going to look halfway between 0 and pi to get the first quarter, and then you're going to look halfway between pi and 2 pi to get the third quarter. But that would be the same no matter what period you were dealing with. You want the halfway, and hence the quarter way and the 3/4 way mark. I'm going to write those points down here just on the side, and this is something I would encourage you to do as well, because as I said, those 5 dot points are what makes the basis for the accuracy of our horizontal translation. Okay, so going back to our translated function, as we said before, we're translating pi on 4 units to the right. So what we're going to do is take each one of those 5 dot points and, as you can see, move them across to the right. So effectively what we're going to be doing is taking these black numbers here and adding pi on 4. The easiest way to do that is to make sure that all of our values have the same denominator. It's like any other fraction work. When you're adding fractions, you want to have the same denominator. So that's what I've done here. You can see in blue, all I've done is change the black numbers into a denominator of 4, and then I'm going to add pi on 4 to each of these blue numbers. So you can see 0 becomes pi on 4, 2 pi on 4 becomes 3 pi on 4, 4 pi on 4 becomes 5 pi on 4, and so on. So I've just deleted that original graph that we had there. If you were doing this yourself, you might have drawn that graph that was there just in light pencil. And now you're going to focus on these red numbers, and we're going to plot them. So the first point is pi on 4, and that starts in the middle because it's a sine graph. So we're going to go middle, top, middle, bottom, middle. And they're all located at the x values given here. So we've got pi on 4, 3 pi on 4, 5 pi on 4, 7 pi on 4, and 9 pi on 4. Of course, this will be easiest to draw if you have your x-axis already broken up into pi on 4. So there you have it. What we have is our basic sine graph that was translated pi on 4 units to the right.